Way back in the day, you might have seen this thing somewhere or another. Maybe through the demo feature of some game, maybe the Jet Set Radio Future combo disc, or maybe at a kiosk at some retailer. This menu is called Xbox Demos, or XDemos for short. I just made a whole non-matching decompilation of this little thing, and that's what I'll be talking about today. I want to cover why I think this decompilation matters in the first place, all the things that this game can do, which is more than you probably ever saw, what the decompiled code does, at least at a high-ish level, and what all this means, or does not mean, for decompiling Xbox games in the future. So, let's get started. Alright, first of all, why? Why spend 4 months decompiling this tiny, forgotten thing? Lots of the usual reasons for a decomp don't really apply here. Nobody's interested in modding this thing, I think, and this decompilation isn't really recompilable in the conventional sense. It can be recompiled if you have an IDE that's not distributed anymore, and an Xbox SDK that's never been legal to acquire, and some middleware used in XDemos, but you can't just clone and compile like you'd prefer to with a decompiled game. I have 2 big reasons for doing this. One technical, and one historical. First, the technical one. While XDemos clearly isn't a full retail game, it's still a functional game by many metrics. It has most of what you expect in a game, like visuals, music, sound effects, handling input, and even some debug code. This means that an XDemos codebase would be both small and fairly complete as an example of an Xbox game. It's a microcosm of Xbox programming, 5,000 lines that you could read through in a single afternoon. As for the historical side of the matter, this thing existed. It's a little minor, a little obscure, and could easily be forgotten, but now we have it in source form. The XDemos code is like a time capsule of how a game was made back then. And to really hammer that point in, after I had finished the decompilation, I spent another 2 whole weeks rewriting it all in period-accurate Microsoft style. All their customary type defs, the redundant Hungarian notation, everything I could see in samples of code written by Microsoft at the time. But besides all that, the actual functionality of the code has some historical information too. The thing is, XDemos had something of a lineage. It started with these early kiosks, turned into the XDemos we see here, and was then succeeded by something called CDX, or Content Demo for Xbox. And when you open up the code, you can see that the transition to CDX was already starting in unfinished and unused parts of the program. To me at least, that's a really cool discovery. Alright, now, having hyped up the contents of this thing a little, let's take a real close look at just what XDemos actually does. I'll go in order roughly from the most obvious functionality to the most obscure. First, clearly, there's a menu that you can navigate and scroll, with a preview of the selected item shown beside. Also, pressing left or right moves up in the menu for some reason. Selecting an item launches the selected game or plays the selected video. More interestingly, starting a game demo and then exiting back to XDemos restores the position and language that the menu had when the demo was selected. More on changing the language later. A few seconds after XDemos starts, disconnecting all controllers will show a message asking to reconnect them, but this won't happen if you never had any controllers plugged in to begin with. The Xbox's settings can affect the menu, both displaying in the Xbox's configured language and hiding any demos that are blocked by its parental control settings. Depending on whether XDemos has been configured to run in what I'll call kiosk mode, a couple behaviors will vary. If it's disabled, for instance, you can press the B button to exit, usually bringing you back to wherever you loaded XDemos from, like the Blink's title screen. If it's enabled, an attract mode will run on a timer if there's no input for a while. Games and videos can be configured to only appear in the menu, or only appear in the attract mode, and XDemos can also remember where it was in the attract mode queue after running a game, just like how it remembers the position in the menu. And lastly, kiosk mode enables a kind of hidden language picker that can be opened by pressing the white button. That's how you change the language at runtime, and XDemos will remember the chosen language when booting back up from a game demo. The last user visible feature is that the visuals are configurable. They are not configurable by the user, granted, but you can see that different distributions of XDemos had different backgrounds. All textures can be swapped out like that, and the menu and preview can be moved around as well. Each specific game can also be given its own please wait screen for launching, too. Finally, while I'm not aware of this thing ever having been used, if the texture for the background isn't fully opaque, a video can also be played behind it to get an animated background. It certainly could have looked pretty cool, at least. Now then, how do all of those features I just described work? And where's all the unfinished stuff that I mentioned earlier? Let's take care of each of those things with a quick walk through how everything's implemented. I'll keep it short, to the degree that I can, and high level, but it's nevertheless where all the juiciest stuff is, so bear with me. Just to set the stage here, this is a C++ program. That means that we start with a main function, which does a bunch of setup and then runs a loop forever, handling input and rendering each frame. The very first thing we do, then, is check if whoever launched XDemos passed some data to it. The Xbox can only run one program at a time, but one program can send along some information like this when switching to a new one. XDemos uses this to store and retrieve the menu state by passing it along to a demo when launching it, and the demo then passes it back when relaunching XDemos upon exiting. We'll see where it actually gets used later. Some of the code can be a little redundant. We get the current time from the CPU clock and add 75 seconds to it to get the time that attract mode will trigger at. But we'll do the exact same thing again at the end of the setup later, so this was pointless. Moving on to real setup, we initialize Direct3D. I probably should have mentioned earlier that the Xbox uses DirectX interfaces from Windows. That is, it was designed as a DirectX box, hardware that just runs DirectX. Some parts are naturally not applicable to a console, like running in windowed mode, but they end up just being unused parts of the interface. In any case, Direct3D here uses a traditional double buffer setup, where one of two buffers is visible at a time, you render to the buffer that's not visible, and you swap the visibility of the buffers once you're done drawing. It uses a lot of memory storing an entire second frame buffer, but it ensures you never display an unfinished frame. Next, we load XDemos.xdi, a file where all the metadata about demos is stored, plus some configuration like available languages and whether kiosk mode is enabled. For each demo, we have names in each supported language, age ratings, whether to show it in a trap mode or the menu, and so on. The file can be either in the file system root, which makes sense for a standalone demo kiosk in kiosk mode, or in an XDemos directory, which makes sense for packaging with a game like Blinks. Either way, other important files will be assumed to be in the same directory as the XDI file. The XDI itself includes a checksum to ensure its contents are valid, too, else the reading will fail, some default settings will be set, and the setup will continue. Speaking of looking for files, though, our first real interesting bit is what happens if a file isn't found. If XDemos.xdi isn't found, a breakpoint interrupt is called, which would allow an attached debugger to examine the state of the game if we were on a developer console. From what I've read, it's official Xbox policy not to ever include this sort of thing in a retail release, but I guess stuff made by Microsoft gets some extra leniency. If another file isn't found, though, we call some peculiar error handling code. First of all, it writes out a debug message that developers could read through a serial port on their console, which is another thing that retail games are never supposed to do. Said message always ends up being the name of the missing file. We also render something to the screen for the first time, a simple gradient over the whole screen. To keep it brief, drawing something basically means plotting vertices, here on the four corners of the screen, and filling them with a color, gradient, or texture. What's peculiar, though, is that this code doesn't seem finished. For instance, we try to load a section called critical error X from the executable, where X is an ID for the active language. No sections like that exist, though. There's also a second rectangle that we initialize but never use. My best guess is that there would have been a section for each supported language containing a localized error message, and that would have been written to the unused rect on top of the gradient background. It definitely would have been more friendly to a user than this unexplained blue screen, at least. All the textures come from a file called XDemos.txt. We make a little class that can read the textures within it sequentially. They're not in any fancy format, but are totally uncompressed and ready to be passed to Direct3D for use as is. We also read two skin files, XDemos.skn and textskin.skn. Each is just a bunch of 32-bit integers for customizing stuff like where the scrolling menu appears or where the preview shows up. You'll see why there are two later on. Reading from controllers works by creating a handle to each one and querying for the respective controller's state whenever we need it. We make handles for any connected controllers here, and actually reading from them will happen in the main loop later. Next thing is getting all the audio set up. We initialize direct sound, load some sound effects to play while navigating the menu, and open up a stream for the ambience to play in the background. You can see here how short and long audio is handled differently in most games. Short sound effects are just loaded into buffers that are ready to be played at any time. But longer stuff like music and dialogue has to be streamed, loading only small chunks at a time on demand so that we can read and play it simultaneously. Here, we do that by setting up 8 buffers, each filled and then played in order. Once a given buffer is done playing, it gets filled up again with new data to play later. This difference between short and long audio is also why sound effects and music use different file formats in most games. Last thing before we get to the actual menu is the language picker. The language names in the language picker actually change with the display language, so every language name has a graphic for every supported language. Every language name also comes in both highlighted and non-highlighted variants, which leaves us with a lot of graphics to set up. Normally, these graphics are loaded from the text file, but something different happens if we switch the value of a boolean in the code. Setting that variable enables what I'll call the unfinished text skin, which uses the textskin.skn file mentioned previously instead of XDemos.skn. When the text skin is enabled, the code looks for a font on the disk, which we have to add ourselves, and uses it to render the language names at runtime, where the names are taken from XDemos.xdi. That means we don't have to provide a whole bunch of textures for every language in the language picker. Also, as a fun fact, we leak a little rectangle here by allocating it twice. Now to start work on the menu itself. We create recs for the background, arrows, and loading screens. Interestingly, all of these can be set per language. The loading screens for launching a game and exiting with the B button are also stored separately, meaning they don't actually have to be the same. These are normally all loaded from the text file, though if text mode is enabled, there's a little unfinished code suggesting that these textures would have been read from separate PNG files instead. Then we set up recs for the menu items. With text mode disabled, this is just more textures from the text file, 2 per item per language, one highlighted and the other not. Text mode, of course, reads the names and descriptions of each item from the XDI and renders the text at runtime. We also set up the previews, which can be either textures from the text file or videos in either WMV or BINC format, the latter being popular third-party middleware which exists to this day. The use of WMV is also interesting since only some Xbox SDK versions supported it, with others supporting only a custom XMV file format or no video format at all. A video, in any case, is basically just a stream of frames we can render to a texture each frame, plus an audio stream that will keep muted for these previews. I'll talk a little more about how we handle video playback later. Turning to the demos themselves for a moment, we filter them by rating, which is stored in the XDI, and sort them, by a key also included in the XDI. For whatever reason, now is the time we decide to set the menu state to whatever the calling program passed along. With that out of the way, knowing which demos to display in which order from the filtering and sorting before, we then calculate their positions on the screen. We also set the recs of those menu items to the active language. For the selected item, we're going to add a very tiny glow effect on the outside border, which we create here. With the text skin enabled, we get the glow thickness from the skin file and generate a glow accordingly. Without it enabled, we read a glow texture from the text file instead. The next setup function doesn't actually do anything. I expect that its contents are removed with an ifdef, though I don't know why they wouldn't just ifdef the whole function and its call as well in that case. If I'm right, the function probably housed some debug or unfinished code. If there's a background video on the disk, we load it up here. For some reason, if there is a video, we also initialize the WMV player for video previews. I have no idea why, because this is completely unrelated to the background video, and the WMV preview player gets initialized right afterwards regardless. We also have a function for updating the menu to account for any changes to the selected demo, setting the scroll position and starting the preview video. Here we call it to put everything in a valid initial state. The last thing we do before the main loop is resetting the attract mode timer yet again, for some reason. And finally, we reach the main loop, which is the code that's running when you actually interact with XDemos. In many games, the main loop runs once per displayed frame, that is 60 or 50 frames per second depending on region. But here, we actually have no frame limiting, and just run it as quickly as the Xbox can manage. On my computer, CXPX can run XDemos at over 1300 frames per second. The first thing we do each frame, at least if kiosk mode is enabled, is check whether that timer we've set for track mode has run out. If so, we start up the next video or game demo in the queue. Next up is taking care of the background ambience. As described before, we check up on all our buffers, setting a new one to play once the previous has been exhausted, and reading new data into any finished buffers. Now for handling input. We first check if any controllers have been connected or disconnected since the last frame, and open or close handles accordingly. Then we loop over all our handles for connected controllers, checking if their input states have changed from the previous frame. Interestingly, the thumbsticks are snapped to cardinal directions if they're pushed far enough up, down, left, or right. Then we go through a big if chain that checks for each possible new input, in each case resetting the attract timer and calling some function to do something like advancing the selection by 1 or toggling the language picker. The black button, which is unused, actually does call a function, but it has nothing in it, which makes me wonder if it had some debug or unfinished functionality. We also keep a timer for how long a direction is held, which allows for holding a direction for a moment to start moving that way repeatedly. Also, I haven't quite figured it out, but there appears to be some kind of race condition here where disconnecting a controller will frequently lead to selecting the current menu item. Maybe if the controller is disconnected between checking for disconnects and reading the connected controllers? A good deal of code is dedicated to drawing the whole screen. This happens in a function that takes the time since the last frame as an argument, trying to use that time to adjust the scrolling speed accordingly. In my experience though, it doesn't quite work. In any case, while the front buffer containing the previous frame is visible, we clear the back buffer to draw the next frame on. Then we draw the current frame of the background video across the whole screen, if there is one, and the background texture is drawn on top of that. If the menu is empty, either because the XDI has nothing in it or the XDI checksum failed, a graphic from the text file is drawn saying so. Then the preview for the selected demo is drawn, either a static image or a frame from a preview video. Because we want a smooth scrolling effect instead of snapping to each menu item, we don't necessarily draw the menu scrolled to the current position, but instead remember the previous frame's menu position and approach the new position at some speed, calculating the distance to move from the previous frame based on the function's time argument. Supposedly. Then, we draw the actual menu items at the scroll position we just calculated, cropping them to within the menu area specified in the skin file. The currently selected menu item is drawn with its selected rect instead of the unselected one, of course, and we also draw the tiny glow around it. Then, if all the controllers have been disconnected, we pull another texture from the text file to ask to reconnect one. Lastly, if the language picker is active, we draw a translucent black overlay over the whole screen and all the language names, drawing the highlighted variant for the active language. That's all of our rendering done, so we then swap the front and back buffers to display our new frame. That's the end of our main loop, but I did skip over one thing. What happens when you select a menu item, or a track mode activates and starts a game or video? We check whether we're starting a game or a video, and the former case is pretty straightforward. We first pack up some data to pass to the demo, like the current menu state, the path to the XDemos executable, and whether the game is being launched from the menu or via track mode. The executable path is so that the demo can relaunch XDemos upon exiting, and I suppose telling the game whether it was launched via track mode could be used to dictate different behavior, like the demo running its own track mode instead of booting into a menu. In any case, we plaster the please wait texture across the screen, and then tell the Xbox to launch the demo's executable, passing along all the data we just prepared. Full screen video playback is actually completely blocking. It interrupts the main loop, assuming complete control. We in fact have two code paths here, one for WMV videos and one for Bink videos. But in general, we kill the background ambience, open the appropriate video file, and stream frames and audio from it. I find it sort of amusing that the XDI has a parameter for each video to control its volume, probably so that studios submitting videos didn't have to worry about making their submission as loud as everyone else's. Anyways, in both cases, we run a loop that plays the video's audio and updates the visuals at an appropriate pace until either the video is over or the player provides input to exit. Since we're not running the main loop though, we have to provide our own input handling function, which is mostly copied and pasted from the one used in the loop. One thing that caught me by surprise is that the WMV player actually uses the audio stream to time the decoding of the visuals. We keep track of how far we've decoded the video frames, and whenever our position in the audio stream catches up to it, we decode and display a new frame. I suppose that ensures everything stays in sync. And that's the entirety of Xbox demos. All described at a somewhat high level, sure, but that's still a whole game we just walked through. I'm honestly pretty worn out, so let's get on with wrapping things up. Okay, what are the implications of this decompilation? Decompiling more Xbox games? Not really, since we can't make recompilable decompilations like this. Not to mention that non-matching decompilations are actually really hard to make, since we have no good way of ensuring that they behave the same way as the original game. Proving that two different programs do the same thing is actually a monumental problem in computer science, and I don't think we'll be solving it. Most decompilations get around this by aiming for matching decompilations that compile down to the exact same machine code, at which point you know the compiled game will do the same thing because it's literally the same instructions sent to the processor. The problem for decompiling Xbox games is that we can't legally acquire the Xbox development software used to compile them, which we would need to check if our decompiled code matches. Basing a public decompilation project on an illegal SDK would be a big risk for getting the thing shut down and wasting all of our work. We could, in theory, recompile with another toolchain, but the output wouldn't match even if the source code was identical to the original, so we'd be back to a non-matching decompilation and all the difficulty that entails. Now, I was going to end the discussion here, but since I started working on this, it's been realized that we probably can make matching decompilations for the Xbox. The trick here is that while the original Xbox SDK isn't legally available, the actual generation of machine code was done by contemporary Microsoft compilers that are now considered abandonware. That is, there's still no, strictly speaking, legal way to acquire it, but Microsoft appears to know about and tolerate people using this old software that anybody used to be able to buy. The Lego Island decompilation did exactly this, and the relevant compilers are available on decomp.me for easy experimentation and crowdsourcing. This means you can recompile functions to match machine code in Xbox games exactly, though they get compiled into Windows executables instead of Xbox executables. Yet, it turns out this was exactly how Xbox games were compiled. They were first compiled into Windows executables, which could not be run on Windows in case you're wondering, and then converted by a program in the Xbox development kit into Xbox executables. We can't use that conversion program, but the process isn't complicated, and we already have homebrew software to do exactly the same thing. That gives us a clear path to recompiling matching code and getting it running on the Xbox. Now, nobody's actually attempted this whole process as far as I'm aware, but here's a first step. The first 100% matching decompiled function from NTSC standalone Jet Set Radio Future, which I was able to put together with help from FuseCV. It initializes the stack of 40 matrices the game uses for lots of geometry calculations, certainly a humble beginning. So, in the grand scheme of decompiling Xbox games that people actually care about, this Xbox Demos decompilation probably isn't that big of a deal. Maybe it's just a little bit of software archaeology, or even just a tiny curiosity that I decided to put together. But it is, as far as I know, the first decompilation of any kind for an Xbox title. And I want to see more. I know now that we have the tools and we have the knowledge to embark on full matching decompilations of the Xbox games that people actually play. The last question is, do we have the interest? I'd like to think so. Thanks for tuning in, and thanks to the JSRF Reverse Engineering Discord for letting me ramble through my thoughts on this stuff as I was figuring it all out, especially Fuse. See you later.